Hello guys, welcome to another episode of AIML Talks. So today we will be implementing regression using Python. So let's work on it. And so what I have done is I have created a new GitHub repo, that is machine learning tutorials, in which I will put all the machine learning tutorials out there. So the others are also there. So you can install the RAG tutorials from the previous GitHub links. So all the machine learning tutorials like regression, logistic regression, everything will be implemented from scratch in Python, and I will be putting the code out here. So just save it out there, and for future usage also it will be there in the YouTube description also. So let's move to the code directly. Yeah. So this is the regression file that I have created, and let's see the data. So the data also I have created is a dummy data. It's a CSV data that I have created using X and Y, some random function I have used X and Y. So this data you can download it from there itself, and then you can follow along. Okay, so let's move to the code itself. So in regression we are using NumPy. We are installing NumPy, Pandas, Matplotlib, and then scikit-learn. So you need to install this. Either you can follow the requirement.txt, or you can directly pip install NumPy, Pandas, Matplotlib, and scikit-learn. Okay. So what we are doing is we are importing NumPy as np, Pandas as pd, and then import matplotlib.pyplot as plt. Then from sklearn.linear model we are importing linear regression. This is and then from sklearn.metrics we are importing two matrices. One is mean squared error and another is R2 score. Okay. So after that what we are doing is we are just simply importing the data. So this is the regression we are this regression data that we have created, that we are importing in the form of a data frame. Now in this just to see whether it is working or not, we are printing the head of the data, and what we need to create is we need to create a model this thing in some y equal to mx plus c form. So we need to create a straight line with a slope of m and intercept today itself. So let's see how it comes. So when you load your data for this model building, so you need to have this reshape for x data, because this x data, due to scikit-learn, if you just directly put the values, then you will get some error, that you need to reshape the values. So what we will do is we'll have whatever x equal to your data frame name, then the column name dot values dot reshape -1, 1, and y equal to data y, then values. So y you don't need to reshape, only you need to reshape the x values. Okay. So what I am trying to do is I am trying to print the original scatter plot between x and y, how it is looking like. So I will do it later on. So this we will creating a figure size of 12,6, and we are printing x and y out here. Okay, using matplotlib. After that we are just calling the linear regression class and creating an object, and then fitting it out so model.fit is called, and so after model.fit you need to pass on the x and y variable. So we are passing x and y variable. Then the model will have when you fit the model, then the model will give you the coefficient estimated slope and estimated intercept. So slope you can find the model.coefficient. This is the first, because it is it's not a multi-regression, it's a simple linear regression. Then 0 will contain the slope m. Okay. If it was multiple, then we would have used something else. Okay. Estimated intercept is basically model.intercept underscore. Okay. So if you want to make the predictions of your original x, you can do ypred equal to model.predict x. Then you can calculate the mean square error, the original y, ypred. Similarly, R2 score will be R2 score, y and ypred. Again, we will plot the final values, all these values on a matplotlib. So again, we are having a 12,6 plot, and we will have the original data also, and then we'll have the predicted values out there. We'll have the predicted line and the this is the y predict line is your the regression line that we are trying to create. And these are the details that we have created. So slope we also printed, intercept also we printed, R2 score also printed there itself. Okay, and then these are same parameters we are printing in the console itself. And I have also created a small predict function to predict any new value thing. So for any new value, let's say the new value is 20, and so what will be the new x? So I'm calling the same function predict new x and giving the value new x. This ny new y whatever it will give you a array. So that first value will be your y. So that's why I'm giving taking the zeroth index out here, and then I'm doing is y equal to printing the value of x and y just to check it out. Okay, so let's see how it is coming. So we'll just do python reg.py. So we will get two graphs. First is this initial scatter plot to check the value, and another is scatter plot plus the line intercept and all these values, the regression line, original data, regression line, and all these estimated box. Okay, so yeah, so there are two figures, you can check it out. This is the first figure. So first figure is only having the this is the x values, and this is the y value. These are the all are the y values, and these are the x values. So now you can see there is some sort of relationship. So when we are trying to create a linear regression for it, so this is how we are getting the final value. So this y predicts, this is the y prediction line that we have got. So now any you can see the values are more or less conform to this line. And so while creating MSE, so this mean square error, what it does is basically it calculates the error between this and the actual y pred for this part, and squares it out for all these values, and then it takes a mean of it. Okay, so similarly for r square, r square, I'll do a separate video for it. So the more the r square is towards 1, it's a score between 0 to 1. The more it's between towards 0 to 1, the more better your prediction is. So for this value where we have got a 0.9672, so that's a very good number. So just because this is some sample dummy data that I've created, so for other things it might not confirm, and it may come as a smaller number, but for this particular thing it has come like this. Okay, so let's close these two figures, and we'll see what is the final prediction that we have got. See, the estimated slope has come at 2.5 and intercept is 0.74. So the mean squared error is something like this, and R2 score we have checked 0.97. So for this if I get given number 20, so the y value is coming out to 51.45. so let's see whether it is working on our because this should be y is must be equal to mx plus c. So the new y should be what, basically 20 into my intercept is what, so I'll use a calculator. So intercept is the 20 into slope, 20 y is equal to mx plus c, right? So what is my slope? So let's do 20 into 2.5207 plus intercept is 0.7408. So what we have done is we have rounded it up to up to 4 digits only. So that's why the value will be little bit closer to it, but not the exact value. So let's see what we get. So see, we are also getting 51.14 So basically just because we have rounded it up to 4 digits only, that's why we have got this thing. Otherwise we would have got a better number. Okay, so I hope you like this tutorial. So do like, share and subscribe my channel, and keep coming to this channel for new tutorial on machine learning. Thank you very much.